As you guys can see by the notes, our goal today is to talk about the three possibilities for the radius of convergence of a power series and how to apply the ratio test. That's what we were doing in class yesterday to figure out the radius of convergence. So these are some kind of big words that I want to quickly explain. The idea was we've been writing these infinite polynomials. They're called power series, and they're equivalent to non-polynomial functions. The equality between the two equations is not always good for every single possible value for x that we might have. The best example I can think of right off the bat is we saw graphically we compared this polynomial, which expands out to like 1 plus x squared plus x cubed, so on and so forth. And that's the polynomial that is equivalent to 1 over 1 minus x. And if you think back to that day like a week ago, we saw that as we moved out of the interval x from -1 to 1, the polynomial here and this non-polynomial function here didn't line up very well. To show you what I mean, here's the graph. So the red graph is a non-polynomial function, 1 over 1 minus x. And here's the first few terms of that summation n to infinity, x to the n. So it's 1 plus x squared. And you can see as I add, these more terms, this blue graph and this red graph, they do hug each other pretty well. It gets better and better, but only through x's from -1 to 1. Outside this region, from -1 to 1, it's not even close to correct, and it's never going to be close to correct. So this particular power series, no matter how many terms I add, is only going to be good for x's between -1 and 1. And you might remember that that was because this whole power series links back to that geometric series. So that's what we mean when we say radius of convergence. This power series is a good approximation for this non-polynomial function only from -1 to 1. So its radius of convergence is 1, because its center is 0, and its interval of convergence is from -1 to 1. We're going to look at how yesterday's work helps us determine what a power series radius of convergence or interval of convergence is.